Today we're going to be taking a look at an example of how to expand and simplify two polynomials. I'm going to go through a few examples with you here of looking at expanding and simplifying, and then we're going to just kind of move along into getting tougher and tougher opportunities where we have to kind of look at bigger and bigger multiplication statements where we expand and simplify. Now, if we take a look here, we have the term expand and simplify. Expand is going to represent to multiply things together, and then simplifying is going to talk about combining our like terms. So things that we've done in the past, some of the stuff from previous grades, and some of the stuff is going to be just, again, expanding on what we have done. So the first example here, and I'm going to use my mouse as kind of a cursor here, is we're going to expand and simplify these two polynomials. Okay, 3 being one of them, it's a monomial, it's just a constant, and then 4c being a second term that we're going to multiply together. Whenever we're multiplying these ones together, we multiply our numbers together. So whatever the numbers are would be a coefficient or constant. In this case here, it is 4 times 3, and that's going to be 12. And then there is just a single c remaining. So in other words, we're going to have just one c, and we're going to have an answer of 12c. So 3 times 4 gives us 12, and then we have to combine all of our variables. In this case here, we have a single c, so we put a single c afterwards. Let's take a look at a second example. Here we have the example 5b and 3b, and we're multiplying them together. Again, same process. 5 times 3 would be 15. So we multiply the two numbers together, 5 times 3. Okay, so combine those together. Multiply them together. The second thing we do is we take all of our letters together, and we have two b's, which ends up being b squared. So b times b is b squared. Our number is 15, so that's our coefficient. And then the variable combination afterwards is b squared. And so our answer is going to be 15b squared. And this gives us an opportunity to see what is what happens when we combine these pieces together. Let's try another one. Let's keep going here. Now we're going to add in some negatives into there. So in this case here, we have negative 2x and we have negative 8x squared. Okay, remember that x squared represents x times x. So there are two x's in that term. First step is we multiply our numbers together. Negative 2 and negative 8 is going to be positive 16. It's very important that we are focused on, though, if there are negatives, we have to include the negatives in there as well. So if there's negatives in the term, we include them in the multiplication statement. Now the variables are not negative at all, and so we have x times x squared. Now that the single x here, this one right there, is a 1x. This is 2 x's. So in total, there are 3 x's. And if we remember with exponent laws, which we've taken a look at in grade 9, that when we multiply two powers together with same base, we can add the exponents. So therefore, 1 plus 2 is 3. So there's a total of 3 x's. We combine this together to be 16x cubed. Okay, so 16x cubed. Let's go a little bit more difficult now. All right, so here we go. We have 4y and negative 2z. Now you'll notice that we have two different variables in here. We have a y and a z. They are different numbers, but let's look at the numbers first. 4 times negative 2 is going to give us negative 8. And then we look at y and z. Now there is one y and one z. So we're going to just combine them together and we get yz. So our final answer here is negative 8yz. And that is the totality of this term here. Okay, we're not going to say y squared or z squared. Okay, there's one y and one z, and so we leave it just as like that. Let's bump it up a little bit here. So in this case here, I'm going to put this up really quickly. We have a term on the outside, so that is a constant. That is a single term. In this case here, it's a constant. And then we have what's called a binomial on the inside. This binomial piece, okay, means that we have two separate terms that are being added together. In this case, those two terms are x and negative 5. So there's two separate terms there. Okay, they're different terms. They're not like, which means that we keep them separate. but we are adding them together. So what we do in a case like this is whatever's on the outside of the brackets has to be multiplied to each piece on the inside. So the 3 is going to be multiplied to the x, and it's also just like this here, 3 times x is 3x, and then it's also going to be multiplied to the 5, and 3 times, or the negative 5, sorry, the negative 5, and so that is negative 15. Now we take a look at our two terms. We have a 3x right here, and we have a negative 15 right there. They are not like because of the x and the constant. So when we put them together, we are left with 3x minus 15. And that is the completion of this statement here. Let's try another one, but now we're going to add in a little bit of extra. So let's put it on here so that we can see it. And I'm going to use the arrows again just to kind of help us out. The first thing we're going to do, negative 2c times c. Well, when we do that, okay, we're going to get negative 2c squared. There's a 1 in front of the c that we don't see. Oh, whoops, there we go. Okay, there's a 1 in front of the c that is invisible. Okay, it's there. We have to know it's there. And negative 2 times 1 is negative 2. And there are then 2 c's as well. Okay, 1 c here, 1 c there. It becomes c squared because we're multiplying those two together. The second step that we do is we multiply it to the 4. So we have negative 2 times 4, which means negative 8. There's only 1 c in here, so we're left with a single c. Now again, we have to remember that c squared and c are unlike terms. They're different. This one there are 2 c's here, and there's only 1 c here. So therefore, they are unlike terms, and so we put them together just with adding them. Yes, I know we're subtracting here, but we add them together, add a negative, it's the same as subtracting, and this becomes our final simplified polynomial. Now, I'm going to pause this video here, and we'll come back and we'll take a look at another video that involves when we have bigger values than just a single term.